let's get started. So lab 16, heaps. I'm going to be somewhat benevolent today, and we're going to start writing this in class.
Yay!
All right. Mark, you're the only one that didn't clap.
Clap!
No.
Delete.
You're not part of this group anymore.
So we're going to construct a basic binary heap and perform heap sort. Implement insert, copy constructor, get height, get size, contains, remove first, operator subscript, because it's really just a heap. So the operator subscript is going to return the element as if it was an array. So when I said it's actually a heap, I meant it's actually an array. So it works just like an array. And of course, sort. Woo. Please follow the lecture, as some of this will be done in class, and the sort function works a little weird. So let's go ahead and jump over real quick on interface. Construct a heap, constant int len. That's going to dictate the size of the heap. And then down here, of course, we copy it from an array, insert a value, get the height, get the size, ask if it contains something. Oh, if you want it to contain something, can you do a binary tree search on it?
What?
No. No. You have to go through every element. I put this function in here to make sure you understand that with a heap, running contains makes really no sense. You have to search the entire thing. And so it's an O of N operation. So if you're doing something that has contains, heap is not a good solution. Return the element of current operator, remove the first, which returns that element, and then heap sort, and we'll get to that in a moment. But let's go up to the top. We're creating a heap. Let's see, filling out in class, we got a good 35 minutes. Let's see how much of this we can do. All right, guys. Log in, by the way.
I've been trying.
Try it. Wow, no one logged in.
I've been trying to all class.
Okay, can we help you?
It says connection refused.
Oh, I could tell you something.
Maybe just
Oh,
like
nope,
you.
someone's in there. So what's up? It's obviously not on my end.
Is this same as I'm going to do any apps? So
Yes, do that. No, it's SSH.
do you remember to connect to the Ethernet?
Yes, but did you configure your Mac to go on the internet and not the Wi-Fi?
Wired connection. Why are you on Wi-Fi again? There's no
Maybe he
internet
wants to be on the
again?
Wi-Fi.
It showed internet earlier. No.
I just work here.
I'm gonna get started.
What's that? Oh, there we go. All right. So a heap is really just an, yes, it's an array. So let's create an array. Let's make it a pointer so it's an array.
Yep. Oh, I forgot about that. It's been so long.
It's been 3 days. It's been so long.
No, specifically for making arrays.
Oh, okay.
Specifically that.
All right, let's also maintain the size of the array so we don't lose what that is. Or we could use a vector. Which would you prefer?
Which one do you think is easier or more useful?
The one that's easier is this. The one that's going to be way more useful is vector.
Then probably no.
Now would be a good time. All right, let's go look up vector.
I broke it.
Sweet.
Me too.
I like this system.
It
I can
won't even let
sass
me-
anonymously.
It doesn't even show I've got a wired connection. Okay. Is it any bigger?
All right, so if we're going to do a vector, you actually do vector of whatever it is, and we'll call it the M heap. And then we get rid of all that because we're done. Ooh, let's. Now, let me, we got to take a quick moment here because this is where using a vector like this is going to be confusing. And I got rid of my camera, so let's bring that camera back up. We want to keep this on the board, so let's do this. All right, so we have our heap class. This is our class. And since we have I'm just going to call it a vector of t, in heap. If we declare it like this, that means that the heap is part of the class. All right? The other way to do it, and I'm going to recommend against that for now, but it needs to be clear, is that if I were to put a, oops. Okay, whoever made it smaller, stop it. If I were to make it a star, then this would point to a heap that exists somewhere else. And then you'd have to allocate and deallocate it, which is why I recommend against it. The problem is, when you allocate this class, it's going to automatically allocate this array. Bless you. You just need to keep that in mind, that automatically creating an array when you create this class, which means you then need to resize the array, so it'll take care of that for you. Hopefully that made some sense, because while subtle, it is a very important difference. Wow, I never even drew it on the board. All right, people online, if there was a star right here, this would actually be a pointer to an array somewhere out in the heap, and then everything I just said. So I'm going to get rid of the pointer, we're going to make it part of the record or the class, sorry. Totally professional. Okay, well that was great. You know what's nice about that? We only have to worry about one variable now. It's called mheap. Whoops. We got heap.cpp, perfect. Hey look, I already wrote some of these functions out. Oh. All right, so if we're creating a heap of a certain size, what can we do? Vector. Resize. I like this. What does that thing do?
Changes the size.
Whoa. Resizes container, so it contains in elements.
Oh.
No.
So we call resize passing in.
Size.
How we do it? Okay. Now, when I said we didn't need another variable, that was a lie. We do need one. I'll call it the m. Wait, did we go with camel case or snake case? I keep forgetting.
We don't care.
All right, we'll go camel case this time. So m heap size is going to be 0. All right, think about this. The resize of len makes our vector have so many elements, but we have 0 elements because we haven't added anything to the heap yet.
Yeah.
All right?
So it's just empty.
It's empty, but has a capacity of len. All right.
The capacity is just how much we can currently put in it. But
Correct.
Right now, there's nothing.
Correct. All right, so let's think about insert. What's the first thing we did on insert?
We have to get the number. I don't know what the word is.
Where do we put it?
Yeah.
The end. All right, how do we put it on the end? So m heap.
I'm thinking of nodes, and that's not right.
Right, we're on array. We're in array land now.
Yeah.
Someone type-
I'm so used to the whole
Do we
node
just
going left and right. that
Add
it's
the
tripping me
number
out.
to the end of the array.
Yes. That's the first thing we do, correct. So do that.
Is it the end, or it's the first slot that doesn't have a number?
What's the
Both.
difference?
Because if you allocate it bigger,
We're not noting anything, so we shouldn't just
Okay.
add it at 0.
Is
I
it
just
that?
don't know.
So-
Centers. We're adding at heaps.
Go back. Delete. Backspace. Oh, no, you had it in heap. Solid open bracket. All right. Where are you putting this thing?
At the end.
Where is that?
The end. I don't know.
Which variable is telling you where the end is?
Length. Size.
Yes.
Yeah.
Yeah. Equals. All right, are we done?
Yes.
Sure. Okay, let's test it. Oh.
No, we're not.
Oh, nice. Golf clap. Golf clap. Everyone golf clap. Golf clap. All right, we need to test this, so let's get the operator subscript going, and I'm going to help you with this because it's really easy. Look, everyone's a critic.
It's too early in the morning.
Holy crap, that's
Now, what was beautiful about that is how instantaneous. That was great. Thank you. That was beautiful.
It was just so sudden and abrupt, and it came from the silent person right behind me.
she's
No,
like,
the
I'm not-
first time she speaks. So let's create a heap of integers. We'll make it 100. Great. We'll do heap dot. What was it called? I already forgot. Insert. All right, sure. Insert. What number do we want to insert?
50.
50. And then we'll do for int I equals 0, I is less than 1, because I want to be able to copy pasta this. Actually, do we have a print function? Oh, that would be great.
we don't do.
We're adding one.
Remember.
We're adding a print function.
Neat.
Amen.
Thank you.
Actually, that's pretty easy. Just
Yeah, it's
for loop in heap size.
it's pretty easy. I don't know why I didn't already write this for you. Oh, because I want you to do it. That's probably the case. Cool. How about that tabbing?
Woo.
Whoa. I wonder if that compiles.
Well, then,
We're gonna find out.
Nope. Damn heap was not declared in that scope. Let's call it the correct variable. Bless you. All right, it printed off 50. Hey, we're correct so far.
No.
What else do we want to insert? Let's insert 100. So 50 comma nothing else. Huh.
we need to make it scaled to in heap size.
That didn't make any sense. Let's try that one more time. Maybe we forgot to save.
No.
No.
The function's not scaled to in heap size.
Oh yeah, look at that.
Like I said.
Let's try that again. Oh, 50 and 100. There we go. It's printing everything. Wait, is that in the correct order?
No. No, that's not.
No. No. Not at all.
That's what's happening.
Well, that's how we're currently making it work, though, right?
That's what the code is doing, but is the code correct?
Probably
Well,
not.
we haven't implemented everything else here.
Oh, okay, sure. All right.
In the confines of what we've done at the present.
So add the element to the end to maintain balance and left justification.
Should we make the heap size not always plus plus and only if it's like running out of space?
Oh yeah, because wait.
Or is it supposed to plus plus anyways?
And And theoretically, we never run into our end if we just name it 9,000.
Unless your professor throws a million elements at it.
Alright, well, let's just make it.
Fair point, but
He would do it. He's like, I'm gonna auto-generate 1,000 numbers.
Let's just
Oh,
put
I know how
it-
to do that. I do a million. Forget it. Once you have the function that auto-generate, you just keep throwing things at it. Who cares? All right. So we've added it to the end. That's not correct. What do we need to do next?
We
add
need
to the end, then
to sift
sift
it.
out.
Sift it. In which direction?
Up.
Up. Okay. All right, so let me help you out here. Left child is, someone type that for me.
Why can't we do
Oh, I'm
right
sorry, that was a terrible, terrible lie. Let's try that all again. Huh, whew.
There we go.
Dr. West?
Yes.
We should do right child and wrong child.
We should do that. How many of us are wrong-handed here? Really? Everyone's,
Right child.
you know, there's right-handed and wrong-handed?
Oh.
He's wrong.
Oh.
You're
okay,
wrong-handed?
yeah.
Oh,
You're a wrong child.
yeah.
Well, I'm the best. Everyone else.
Correct me if I'm wrong,
Yeah.
we should put the
Yeah.
heap size increment at the end if we're doing it like this.
Okay,
So
that's a
that-
good idea.
So that maintains its current index for going through parent index.
Sounds great.
So that's.
All right. So, then what do we do?
The children.
No, we don't have to do the children. Remember, we're sifting up, so we don't care about our kids. We only care about our parents. We're going up. You're looking up at your parent, not down at your children. Wait a minute.
Or next
Anyway.
to
Why not just look down on them?
I'm talking about that physically. There we go. You look up to your parent because they're larger than you when you're a kid. Yes. And then when you're a parent, your children are smaller, so you look down.
What if your
There's the
parents really
analogy.
short?
What's that?
What if your parents really short?
I'm
Your
taller
parents-
than my mom.
My mom's short.
Well, no, when you're a little kid.
I'm still taller than my mom.
At what time? What age were you taller than your mom?
No. I'm not when I was like 5, but.
It's kinda like,
Look, work with me here. What do we do next?
Um,
Compare it to.
Yes, let's do that. If, sure, we'll do an if.
if the child is bigger than the parent. Is that what we're getting at?
I feel like there should already be a recursive statement.
We could recurse this, sure. But this one actually is easier to do iteratively, I'll tell you that right now. The reason why this one's easier iteratively is because you're jumping through an array, so it's easier to keep the index, as opposed to trying to do the pointer arithmetic, which in this case will be very annoying.
Yeah, the moment you introduce those concepts, I have a feeling that it's trying to do what recursive is going to.
This is a recursive, but it
Yeah,
ends up
you-
being
that
that this
you
one's
point
easier
for
iteratively.
recursive.
It's just, this one just ends up being easier that way. And it's because we're working on an array, not on pointers. So since we're working on an array, in general, the iterative one is, well, in this case, the iterative one's better. Although with quicksort and merge sort, the recursive one I think is simpler. Okay. All right. I'm going to help you all out and create some separate variable names because this is going to get really confusing really quick.
Yay.
So int current, the C index, that's the current index, would be the imp heap size because that's where the variable is stored. And I think that's, then we can increment heap size, and that way we can create instead of this C index. All right, that's going to make it clear.
Then we should change the M heap size that I use for the parent index to C index.
Thank you, Blake.
I definitely would say Syndex instead of C index. It's like Windex, but starts with a C.
See, it's like Syndex, except for that's starting to sound like it's with an S, which
Well,
means
if we're pronouncing it phonetically like we would GIF, then it's Kindex.
Kindex.
index or C index. Yeah, whatever. Then why is it called C in and C out, not count or sin or whatever?
I call it that sometimes.
You call that
Sometimes.
count,
Gotta mess
or
with
is it
people.
sout? I think it's count. Count.
Man, imagine if you pronounced all of this weird stuff phonetically. Stood.
Oh, you wait till you get to operating systems and start talking about OS concepts in like front of an English major. They'll just get offended.
Yeah, well, they can be offended. This is my area. It's not theirs.
That's right.
This is
They'll
what I
just get
spend my
offended.
money on.
Phew. All right, we'll save that for OS because we're in data structures now. All right, so if the C index is greater than the parent, what do we do?
So you swap.
Swap. All right, swap it.
I wish I could.
You just do it.
Just do the thing.
All right, keep going.
There are.
Yeah, right.
What's that?
I
didn't hear
Uh,
That was great.
Do I want to know or?
It's from Shrek.
Oh.
You know, Shrek observed that the weird little blonde kid at the beginning. It's like, do the roar.
Oh, okay. Wait, that's not the first one though.
No, the third one.
Oh. I don't know if I've seen the third one.
Or is it?
It's not the first one.
Yeah, no, it's definitely.
I think I've seen the second one.
Yeah,
You
maybe
said
second.
just like him.
That is the fourth one.
Yeah.
It's the fourth. Oh my
There's
goodness. There's a fourth one.
Yeah.
Yes, and there's like other little ones too.
Oh, I think I've
It's like the Land Before Time.
Nobody's bothered by the fact there's donkey dragons.
Oh no,
I
we don't even
mean-
talk about how that occurs. That's just, you don't
You
think
just
of it.
accept it. Don't ask questions.
Okay. Let's see what that does.
Please work.
I mean, is it any weirder than a manticore?
Hey, look at that.
Chimera?
So let's go and do the whole
It's data
TS.
science.
We're talking about the fancy one.
Which is.
Oops. That way we can actually confirm that's working with the certs, and that way if we mess something up, it'll tell us later.
So what does TS assert do?
TS assert means that evaluate this. If it evaluates the true, everything's cool. If it evaluates the false, that means that your code has failed this test case and you need to tell us what the error is. All right, let's make another one.
Code is lame, it doesn't work.
The code is lame. All right. Let's put that down. All right, let's add another number. What else do we want to add?
150.
150. All right, let's see if that works. 150, then 50 and 100.
That's not right.
No, that's right. That's right, because the parent is 150. The two children are 50 and 100. Yeah, so that's cool.
I was thinking
Maybe
about
we
it
should
left
start
and
one
right.
with the index. Not the index.
No, we're doing great. We got to add another one.
Let's
Let's add another one. Let's add 250.
Did we break it?
Not yet.
Oh, so
It's gotta be able to go up twice.
it's got to be able to go up twice, but
That's
this is
not
a
a-
data structure, so it needs to be able to go up every time.
Yep.
Be like
Like a-
while root
There we go.
is,
While, there we are. And then you need to update the parent index down here. All right.
Yeah.
Anything else we need to do?
Wait, wouldn't
Or
would
not
C
the
index
parent.
not adjust in size?
So we need to actually do, I'm sorry, C index equals parent index, right?
before parent index updates or after?
Well, you got you
So
before.
it does the current parent index and then cycles through the C index to get the one behind
Get
it.
the new parent.
I love it when students answer the questions. Nice.
Get the grandparent.
Right, because you are going to become the parent.
So I'd rather not.
You're just like, I'm better than these, so I become the parent.
I become the parent. Exactly. Exactly.
You're garbage at parenting.
All right. Anything else we need to do?
Hope it works.
Hope it works. Ah, yes. Let's run on hope, because that always works every single time. Ooh, hey. All right. Let's go save that test case.
Hope has saved us.
I forgot. It was 250, and what was it? We'll just make sure the top one's 250 and call it a day. All right. Let's see. Actually, I think that might be all we have to do because we said strictly greater than. Oh, okay, great.
Nice.
So what happens when if C index becomes 0, 0 minus 1 is -1 divided by 2 is actually 0 because it truncates it. So yeah, this code wait, this code's gonna work. Are we done? We might be done, except for that whole thing, you know, check if the heap has enough space, but I'll let y'all do that. So yeah, that's looking good. So the one other thing I like to do,
Remove.
whoa, hold on, we're not done testing. It's called srand. No, not seed rand, I'm sorry. Rand mod 1000. And hold on. That is not what I wanted. Let's try that again. Oh, it's man 3? I can't even remember. There we are. Oh, it's part of the S standard lib. Perfect. All right. So let's see the random number generator with, I don't know, 200. That sounds great. And let's make sure we include standard lib. Then we go down here. Let's print it off. What this does is seed the random number generator with 200. That way it creates the same 100 random numbers. Yes, I said that correctly. I'll say it again slowly. You seed the random number generator with 200. That way it generates the same 100 random numbers afterwards. I said that correctly.
So there's usually 100 of the same number, is what you're saying.
Yes, randomly generated.
Is it random though?
Oh boy.
If it's
Oh,
the same
boy.
thing, and it's gonna get the same thing.
That's a philosophical question.
Don't ask that question. You're not.
Does entropy actually exist?
That's a big word.
Bless you.
No.
Does entropy actually... Ooh, you say no. So you're a determinist. So everything has already been determined.
Yes.
So.
Then we don't have free will.
No, it's just we don't know what has already been determined. And it'll be
Right, we
like-
don't know,
But our free will.
but then we don't have free will because it's already been determined and we just don't know it.
It's been determined.
Or-
you just don't know
Nah.
it. So like you're like, oh well, someone's gonna think I do this way, so I'm gonna do it this way. But the determine's like, oh, I already know you're gonna do it this way, even though you're gonna think I'm gonna do it this way.
So you're saying there's the illusion of free will.
I'm saying they already know what the free will is. Like
They.
what we'll choose.
I think I've...
Therefore, it's determined.
Therefore, it's... So we got a determinist.
I agree. It's just it's determined on your free will.
It's
So,
determined on your free will.
Never heard it that way.
Yeah.
So it's actually determinist. There's weak free will and strong free will. I'm the weak free will guy, by the way. So determinist, everything has been determined. The strong free will is you have free will to choose whatever you can. The reason why people usually have problems with the strong free will is that means that God doesn't know what you're going to do, because if you have actual true free will, then there's no way to know what your next choice is going to be. The weak free will, which is kind of a hybrid of the two, is God knows what you're going to do, but you get to choose in a way how you're going to do it. As for example, if you're on top of a diving board and you're at the end, God knows you're going to jump off, whether you choose to do it or the guy pushes you to get off, it's still going to happen.
See, I think he already knows what's gonna happen, like if you're gonna get pushed or if you're gonna jump.
He does. The point of the analogy is to point off the subtle difference in that there is, you get to choose, you do have your choice in the end, but God already knows what the final outcome is going to be. He knows what the final outcome, how it's going to end up in the end, but you are allowed to choose how you're going to get there if you do. Well, he already knows what you're going to choose in the end. What?
I would lean toward that.
Right, so you're weak free will, yes.
See, I think he already knows exactly what you're gonna do, but he allows you to do it anyways.
Sure, okay, so then that's determinism. So then random numbers don't exist for you. Because there is no,
Random.
right, so it's pseudo-random. Well, that was fun. Where were we? Oh yeah, make heap test, here we go.
We were grading on the
Whoa! Oh, you know what happened?
Look at all those F's.
Well, what
That's
happened?
nice.
Oh, it's so, oh, I'm sorry, let me show you what that all means.
That's white right there, all the F's.
So I can't scroll up because I forgot how to do that in TMUX, but these are a bunch of errors inside the library, which means that you overflowed memory. Probably because we told the heap to only have 100 elements and then pushed 104 on them. So let's give it 1,000, see what happens. Or, hold on, I think I accidentally hit enter twice. Oh, there they all are. Look at those random numbers. All right, so is 996 greater than 974? Yep, and 974 greater than those two? Yep. All
I
right,
see an 800 all the way down there.
that could be correct.
Oh, it could be.
Oh, it can be.
It's just
Because
on track after like the fifth.
Oh, no, it can be, because if it's going on the right side, then this 800 just needs to be less than 955, which needs to be less than, oh my goodness. Not these two, the 904. Yeah, so that can be it, but I have to sit down and evaluate each one.
So the
So
larger
this-
it gets, the harder it's gonna get to track.
Oh, yeah.
Yay.
You're welcome.
See, if we put it all in like a Word document, then you can evaluate it easier.
How?
Because then you can like kind of separate it out to what the indexes are or kind of tree it up.
Oh, you'd have to draw the tree out, though.
That's fine though, you can just like drag the numbers.
I thought there's a website that does it.
All right, so I'm going to just let that one be.
See, when you said that you seed the random, I thought that literally the exact same number would come out because you're
No.
using the same seed.
So the seed is the
Same,
beginning
like,
of the.
number
Oh.
It's a
within
sequence.
certain range.
It's a sequence.
Oh, it starts at 200.
So the way that, no. Oh, yes, I'm sorry, yes, that's a good way to think of it. It starts at
Okay.
200.
It doesn't
So you're
really
at
know.
200, and the pseudo-random number generator has a formula to pick the next pseudo-random number. And so based on 200, what's the next one? Then based on that number, what's the next one? And the idea is that it's supposed to be able to cycle through the entire space of what an integer can hold, evenly.
Yeah.
So when you call,
The fun part about SRAND is that it gives you the same results consistently. So if you're trying to test randomness, air quotes randomness, with a sequence of numbers, you can always just use that SRAND and it'll always give you the same results. So you'll know if something broke.
What if you did like you did two versions of like the random numbers, so you did a random inside of the random, would it be more random then?
I don't know, determinist. What do you think?
It'd be more randomized than it
What
currently is.
would RAND
It doesn't, it would make
RAND
it.
divided by the modulus operator of RAND be?
Ooh.
It's
True
whatever,
chaos.
no, it's just whatever it is, because it's rand. It's probably gonna be 0 or 1.
I know, but that'd be really funny.
So what
mod? Oh, I'm
happens
sorry,
if-
mod, never mind. Mod, I was doing division,
Like
sorry.
instead
mod.
of that 1,000 right there, there's another RAND.
Well, the reason for the 1,000 is so all our numbers are between 0 and 1,000, so it's easier for us to read.
I know, it'd just be funny.
But it would be kind of funny, sure.
So the other time when we ran out of memory, like what does that show us?
That shows us that, hey, look, we ran out of memory because we threw 104 elements and we only said 100, which means that we messed up on using the data structure. Or Dr. West, threw more elements than you needed, so you need to account for increasing the size of your heap.
Or we can automatically make it much bigger than it needs to be.
Sure.
Just allocate it at 1,000. Just
Sure. That's
Is
it.
it gonna fail test? Is that what you're telling me?
Maybe. Maybe not. Hey, let's do the get size, because that one's easy.
We'll
Oh, maybe we won't do get size. What'd I call it? Was it get size? Oh, so I am using camel case. There's no consistency in this class. All right,
You wish.
go for it.
Wow. Mind blown. My favorite one.
It was my favorite.
I think my favorite is
That's
the
the best one.
deallocated one. Whenever you guys
All right,
deallocate it.
we're going to talk about the heap sort. So, all right, this heap sort's going to work a little differently than what you may anticipate. Performs a heap sort and returns an array of sorted elements. Note the heap is empty after the sort. And I forgot, is there a vector to array function? That would be great. Let me find out. Convert a vector to an array in C++, or do we just have to convert it manually?
Stack Overflow.
Naive solution. Whee! That's string copy. Don't care about that. All right, so you have to copy it manually. Sorry about that. Okay. So heap sort. What you do is heap sort the vector. Create an array of the correct size on the heap. And that's heap, whoops, the memory, not the data structure heap. So with new, so new of the same heap size, copy all the elements in, return that point. Okay?
Why does it have to be on the
Bless you, because if it's on, oh, that's great, because if it's on the stack and you return, what happened to that memory? It's been deallocated.
Oh. That's right.
So it's got to be on the heap. Create an array of the correct size on the heap. Set the elements. Oops. Set the elements. I'm just going to say that. Return the new array. Boom. Oh. Set your heap size equal to 0, because in this situation of heap sort, once you sort the array, it's no longer a heap. So you need to make sure your heap size is 0, or hint. Instead of above, think about how you can use remove.
Popping things off.
So what is
Setting it up.
So where's our remove? Oh, it's not here. So the remove function removes and returns the first element. So it's going to remove it, aka put it in the back. I'm going to tell you right now the easiest way to do this. Take the element, put it in the back, swap it with the final element,
And then
sift that
decrement.
front one down, decrement your size, return the last element of your heap array. If you do that inside of remove, then all your heap sorting is calling remove until your heap size is 0, copy everything to a new array, and then return it.
So you're wanting it to go from smallest to largest.
Yes.
Okay.
Wait a second, this returns a pointer of t, so you can
It
just...
returns a reference to t.
No, I'm talking about heap sort.
Heap sort returns a pointer to t, which
Yeah,
is
so
an
you
array.
can- Yeah, so you can just keep calling remove until eventually you
It's
just
empty.
run out of size.
Right, and then just copy that to an array and return it. Yes. I'm telling you the easier way to do heap sort. In other words, do the heap sort function last, and your life will be easier. All right. So, any other questions about this lab? Good talk so far?
Do Monday, I assume?
Due Monday? Yeah, when else would it be due? Let's see.
Tuesday is Monday.
The what? Yeah, November 4th. I didn't say in here, but you are allowed to use Vector, obviously.
Because we did use it.
Yeah. Yeah.
Every time you say Vector, I think of, what's that movie? Despicable Me.
Yeah.
Ah, okay.
And that guy's face just like pops in my head.
I'm gonna be honest, I don't want this due at the end of the year, because I know this thing will just lurch
Isn't
out
his
of,
name Victor though?
like,
I think
nothingness
it's Vector.
upon me.
Yes, it will.
I don't know.
It will.
I'm gonna look now.
Did I tell you the last time I taught architecture, I said, okay guys, I'm gonna go all out. All your homework is due at the very last day of class.
I don't know if that's a good thing or
Vector.
not.
It is
Oh.
No, it's a thing of nightmares.
Oh, it was, I laughed the entire time.
That's
Because
the
at the
stuff-
end of the semester, they begged me never to do that again.
That's the kind of things that haunt my dreams.
Mm-hmm. It was beautiful. It was great.
I have a question. Are you dressing up for Halloween?
No, I never dress up for Halloween. I've never
Why
dressed.
not?
I don't like pretending to be something I'm not.
You can be a binary tree.
Am I a binary tree?
You can be if you want to be.
That would be cool.
Plus 2019 a non-binary tree.
Oh, that was good. But then what am I? A linked list?
Heap.
A heap? No, that's a binary tree.
You can have all your kids dress up as nodes, and then together
You can
make
be the
all
parent
nodes.
Yes.
And no one would get the joke.
We would. You can send us
You
a
would,
picture.
you're awesome. Everyone else
You can
is
bring them
lame.
to school, and then everyone would be like, yes.
How would you dress up as that though?
You would
I'd be
have
a box with the child pointers, and then each one would have a
You would
leash
have a
going to
box
each kid.
with a leash connected to two other.
That would be great.
It's like the world's weirdest human television set at that point. This is the DVD.
You know how many
this
questions
is
you
the
would
VCR.
get?
That's the PS3 that someone
Oh,
uses, except for
man.
Netflix.
That would be great. Yes, but any other questions, comments? Screams?
Always.
Hmm.
I mean, the vector has a like a back, like where you can access the last element.
Mhm.
So we use that.
Yes, that's the whole point of vector. You can, obviously,
Is it the last?
hold on
element?
one thing. Inside of STL, they have a function called make heap and heapify. Don't use those functions.
Do they not work the right way?
I will issue you a 0 if you use them. How about that? Any other questions? Good point. All right, guys. So we have, I guess, 55 minutes. If you have any other questions, please come see me.